Precision, in the realm of manufacturing, is not just a luxury, it's a necessity. This statement holds weight in every corner of the production world, but perhaps none more so than in the manufacturing industry, where precision is the difference between a flawless final product and one that's destined for the scrap heap. Consider the automotive industry, where the accuracy of measurements can make or break the performance of an engine. It's not an exaggeration to say that even a fraction of a millimeter can be the difference between a smooth ride and a complete breakdown. Every component, from the smallest screw to the largest panel, must be manufactured with an exactness that leaves no room for error. Imagine the piston in a car engine. This small, yet crucial component needs to fit perfectly within the cylinder for the engine to function optimally. Too tight, and the engine can seize. Too loose, and it could lead to a loss of power or even engine failure. This is where precision comes into play, ensuring that every part fits just right. Not just for the piston and cylinder, but for every component of the vehicle. But how does one achieve such a high level of precision? It boils down to a combination of skill, technology, and a deep understanding of the concept of tolerances. Tolerances indicate the allowable amount of variation in a physical dimension, meaning they dictate how much a particular dimension can deviate from the standard without affecting the functionality of the part. It's like a tightrope walker maintaining balance. If they lean too far to one side, they'll fall. Similarly, in manufacturing, if a dimension is too large or too small, it could lead to part failure. Tolerances guide manufacturers in keeping their measurements within a specific range, ensuring the final product functions as intended. So, as you can see, precision is the cornerstone of successful manufacturing, and a key player in this is the concept of tolerances. It's a fine line to walk, but when done right, the results can be nothing short of perfection. Tolerances in manufacturing are the permissible limits of variation in a physical dimension. That's a rather formal way of saying how much we can let a measurement deviate from its intended value before it causes problems. To illustrate this, let's consider a door in its frame. If the door is too small for the frame, it won't close properly, letting in drafts or noise. On the other hand, if the door is too big, it simply won't fit. The acceptable range of sizes for the door to function properly, that's the tolerance. The fit, on the other hand, is how the door and frame interact when assembled. Now, how are these tolerances determined? They're not arbitrary. They're based on guidelines like ISO 26781. This particular standard, for example, provides a systematic method for specifying limits and fits for cylindrical parts. It's a universal language that ensures a machinist in London and another in Tokyo would produce parts that fit together perfectly. In the world of manufacturing, these tolerances are crucial. They allow for the inevitable minor variations that occur in production, while ensuring that the final product functions as intended. Whether it's the fit of a piston in an engine or the snug connection between a headphone jack and its port, tolerances make sure our manufactured world fits together. But it's not just about function. Tolerances also impact cost and production time. Tighter tolerances mean more precision, which requires more time and often more expensive machinery. On the other hand, looser tolerances might speed up production and reduce costs, but at the risk of functionality and quality. It's a delicate balance that requires deep understanding and careful consideration. So, the next time you close a door, plug in your headphones, or start your car, remember the unsung hero of manufacturing, the humble tolerance. Without correct tolerances, our manufactured world would be a shaky and unreliable place. When it comes to manufacturing, every millimeter matters. Now, this isn't just a catchy phrase to reel you in. This is the unvarnished truth in the world of manufacturing. The significance of accurate measurements cannot be overstated. They are the lifeblood of precision, the heart of meticulous craftsmanship, and the backbone of a successful manufacturing project. Let's consider a real-life example to illustrate this point. Imagine you're building a bridge, a grand, towering structure that's meant to withstand the test of time and elements. Now, suppose you were to make a small error in your measurements, say, a mere 2 millimeters off on a single steel beam. That might not seem like much, right? Well, think again. This seemingly insignificant error can multiply across the structure, leading to a potentially catastrophic outcome. the bridge may fail to bear the weight it was designed to support. It can lead to a domino effect where one component's failure triggers the collapse of the whole structure. A 2mm error could result in a disaster, risking lives and causing millions in damages. But it's not just about avoiding disasters. Accurate measurements are also about excellence and efficiency. In the world of machining, for instance, if a part is even a fraction of a millimeter off, it may not fit correctly. This can lead to wasted resources, both in terms of time and materials. It can mean the difference between a smoothly functioning machine and a costly malfunction. Taking accurate measurements is not just about precision, it's about responsibility. It's about understanding that the difference of a millimeter can have far-reaching effects. It's about realizing that every millimeter, every tiny fraction, holds within it the potential to make or break a project. So, whether you're a seasoned machinist or a beginner just dipping your toes into the vast ocean of manufacturing, remember this fundamental truth. In this world, every millimeter, every micrometer, every nanometer counts. The takeaway here is simple. Accurate measurements are fundamental to manufacturing precision. One of the most traditional, yet precise, manufacturing processes is turning on a manual lathe. A tool that has been around for centuries, the manual lathe is the cornerstone of precision manufacturing. The process begins with a piece of material, often metal, which is mounted onto the lathe. The lathe then spins this material at a high speed while a stationary cutting tool is moved along its surface. As the tool cuts into the spinning material, it removes small amounts of it, shaping it to the desired dimensions. This process, known as turning, is a craft that requires a great deal of precision. And why is precision so important? Consider industries like aerospace, where even the smallest imperfection could lead to catastrophic failure. In this context, the role of a manual lathe becomes crucial. For instance, when crafting the turbine blades of a jet engine, the blades must be shaped to within a few thousandths of a millimeter. The slightest deviation, and the engine's performance could be severely compromised. But it's not just about making cuts to the right depth. The surface finish of the turned part also matters. A smooth finish can reduce friction and wear, improving the lifespan of the part. On the other hand, a rough surface can lead to premature failure. Here too, the manual lathe excels, its slow and methodical approach producing a finish that's often superior to that of automated machines. And let's not forget the skill of the machinist. Operating a manual lathe is as much an art as it is a science. It requires a deep understanding of the material being worked, the tools being used, and the desired outcome. It's a dance of sorts, a delicate balance between removing enough material to shape the part, but not so much that it's ruined. Even in this age of automation, the manual lathe stands as a testament to the importance of precision in manufacturing. It's a reminder that sometimes the old ways are still the best ways. And as long as precision remains key in industries like aerospace, the manual lathe will continue to hold its place in the annals of manufacturing history. So what have we learned about precision in manufacturing? We've journeyed through the intricate world of precision manufacturing, unraveling its many layers and facets. In this world, we've discovered precision is king. It's not just a desirable quality, it's a necessity, a defining factor that separates success from failure. We started by understanding the significance of precision. It's not just about crafting perfect parts. It's about ensuring the smooth operation of machines, systems, and even entire industries. When we dive deeper, we realize that precision is not merely a technical requirement, but the backbone that supports the functionality of our modern world. We then moved on to the realm of tolerances and fits. Here we learned that perfection is not always about absolute accuracy, but about meeting specific requirements within an acceptable range. Tolerances and fits, as we've seen, are the guiding principles that allow parts to fit together seamlessly, enabling machines to work in harmony. Then, we ventured into the world of measurements. We discovered that in manufacturing, every millimeter matters. It's not just about taking measurements, it's about taking precise measurements. A tiny error can lead to a chain reaction of problems, disrupting functionality and leading to costly repairs or replacements. Our exploration then led us into the domain of manual lathe operations. We saw firsthand how a lathe operator's skill and precision can transform a simple piece of metal into a complex machine part. The precision required in manual lathe operations is a testament to the craftsmanship and expertise that goes into manufacturing. To sum it all up, precision in manufacturing is not just about making perfect parts, it's about creating a perfect world. It's about enabling machines to work flawlessly, industries to operate efficiently, and our modern world to function seamlessly. Remember, in manufacturing, precision is not just about making perfect parts, it's about creating a perfect world.